In this video, we're going to talk about the intermediate value theorem. The intermediate value theorem says that for any polynomial function p of x with real coefficients, suppose that for a not equal to b, and p of a and p of b are of opposite signs, then the function has a real zero between a and b. The intermediate value theorem cannot be used to determine whether there is not a real zero between a and b. It can only be used to determine if there is a real zero between a and b. All right, so let me explain exactly what this means. Is that if you have a graph and you have two numbers, let's call them A and B, that are obviously not equal to each other, so they're not on top of each other. And let's say you have the output where you have P of A. So this is the actual coordinate point of A, P of A. And then over here, you have B, P of B. What the intermediate value theorem says that if either A is positive and P of B is negative, at some point, when you go from this point to this point, you have to cross this line. You have to cross the x-axis. It doesn't matter what happens here, but at some point, you're going to cross that at least once. Now, you could cross it several times, but what the intermediate value theorem guarantees is that you're going to have at least once, as long as P of A and P of B are opposite sides. What it's saying is that you're going to move the graph from left to right. You're not going to circle around this way, because then you're not going to have a function. You're not going to circle around this way, and you're not going to have a function. It's a function, so it has to pass that vertical line test. And the only way to get from point A to point B, literally in this case, is to cross somewhere on this interval. Now, the way that we actually apply it when we look at functions is we just plug in the numbers and to see if you get a positive answer and you get a negative answer. Let's look at an example where we have f of x is equal to x cubed plus x squared minus 6x. And let's say that a is equal to minus 4 and b is equal to minus 2. So let's check a first. We're going to check f of minus 4. And this is for when a equals minus 4. So we're going to put minus 4 into my equation. Minus 4 to the third plus minus 4 squared minus 6 times minus 4 is going to give me my answer. So I'm going to go ahead and plug that into my calculator. I'm going to do in parentheses minus 4 to the third. I'm going to do plus, then in parentheses again, minus 4 squared, and then I'm going to do minus 6 times, in parentheses, minus 4. I'm going to get negative 24. Now I'm going to try for b is equal to minus 2. I'm going to put that in my equation. And then minus 2 to the third plus minus 2 squared minus 6 times minus 2. And now let's see what we get. I'm just going to hit second enter in here. So all I have to do is go back and change the 4's to 2's. And I got that previous response by doing second button and enter. If you don't have a graphing calculator, you can do the same thing usually, or you can use a D-pad. I'm going to plug that in. I'm going to get 8. Great. Because these are different signs, I know that there is a real number solution between negative 2 and negative 4. If we look at it on a graph, here I've got minus 4, and I have a coordinate point minus 4, minus 24. Let's say that it's about right here. And then I have minus 2. Let's put that right here. And that coordinate point is going to be minus 2, 8. Put it right there. So if I go from this point to this point, I have to cross the x-axis. Now we don't know where that x-axis, where it crosses yet. We actually have to solve the equation to make that happen. All the intermediate value theorem says that it's going to cross at least once in this interval.